All right, we're going to talk about solving systems of linear equations in two variables. So remember, this is what we're trying to do is find where those two equations intersect. So we're finding the point of intersection. So we'll kind of talk about different ways to solve them. I'll talk about how I prefer to solve them, kind of go from there. So here's my two equations, and it asks is 1, 2 a solution? Well, to find out if 1, 2 is a solution, we have to plug it into both equations to see if it works. Right? So when we're here, I plug this in, I get 2 minus 6 is negative 4. Is that true? Yes, that's a true statement. So now I'm going to plug it into the next one. 2 times 1 plus 2, that gives me 2 plus 2, which is 4. That's true. So this is a solution, okay? So if I ever found that it didn't work for one, I'm done. I don't have to go on from there. Now, what we're going to do is we're going to look at graphing. Now, graphing is great for visual representation. The biggest thing I have with graphing is a lot of times we're graphing freehand. And when we graph freehand, we tend to create error, human error. So either your line's kind of wobbly like mine, your coordinate plane doesn't have the same increments, one's a little bit bigger and one's smaller. So that's kind of the issue with graphing, but it's great for visual representation on this. So the first one, I'm going to graph using my y-intercept and my slope. The second one, I'm going to graph using intercepts. Okay, so I'm going to come up here. I'm going to plot this one as orange. Okay, so now I come up, I go positive 1, and then I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. So there's my line, and I do have a little bit of error because these obviously aren't the same width. Okay, now I'm going to plot this one in green. Okay, so I have an x-intercept of 6, right? Because if I cover up the 2y, I have x equals 6. And if I cover up my x, I have negative 2y equals 6. So I'm going to divide 6 by negative 2 and get negative 3. And so now I'm going to connect these two here with the line. And I see that they intersect here, which is 4, negative 1. Now I could test that by plugging it into both of those to see if it is correct. So I have 4, negative 2 times negative 1 gives me a positive 2, so 4 plus 2 is 6. That's true on that one. So now I have 4, so half of 4 is 2, then I make it negative. Negative 2 plus 1 is negative 1. So this is a solution to it. All right. So graphing is really nice for visual representation. The next one is called substitution. So what I'm going to do is I'm going to solve for one variable and then take that quantity and substitute it in. So here I have y equals negative x minus 1. I'm going to take that and put it in for my y. Right? So this becomes 4x minus 3 times the quantity negative x minus 1 equals 24. Now I'm going to do a little simplifying. 4x plus 3x plus 3 equals 24. 7x plus 3 equals 24. Subtract my 3. 7x equals 21, or x equals 3. Okay? Now I'm not done. I need to find my y. So I'm going to take this and plug it back in. So I have y equals negative 3 minus 1, which gives me negative 4. So y is negative 4. Okay, so there's my item here. We're going to do one more of these substitutions. I'm going to erase this just to kind of clear it up a little bit. Okay, so I'm going to take this 2y minus 3, and I'm going to plug it in for my x. So I'm going to take this whole piece here, plug it in for my x. So I have 5 times 2y minus 3 minus 4y equals 9. So I'm going to multiply this out. So 10y minus 15 minus 4y equals 9. I'm going to combine my y's here. So 6y minus 15 equals 9. Add my 15 to both sides. And I get 6y equals 24, or y equals 4. So now I have a y of 4. Now to find my x, I can just plug it back in. So x equals 2 times 4 minus 3. 8 minus 3 is 5. So there's my xy coordinate. Now, elimination, in the elimination, what we're going to do is we're going to eliminate one whole variable. So I want to get rid of either my x or y. And to do that, I have to make them the opposite of each other. So one of them has to be positive, one of them has to be negative, and they have to have the same coefficient. Okay? So that means I can multiply the top or the bottom equation by a constant, or both of them by constants, to get them to be opposite. Sometimes you won't see this be called the elimination method. You might see it called the adding method. That's fine. It's the same process, because what you're trying to do is add them together to get 0. So here, I already noticed that I have a positive y and a negative y. So I'm going to go ahead and eliminate my y's first. So I have negative 8y here, so I want to get this to be 8y. So what I'm going to do is I'm going to multiply by 4. I'm going to multiply the top equation by 4, so that way this becomes 8y. So when I add negative 8y to it, it goes away. So that gives me 12x plus 8y equals, and remember this 4 is multiplying the 48 also. So that gives me 192. So now I have 9x minus 8y equals negative 24. I now add straight up and down. So now I have 21x equals, 68, 168. I'm going to divide by 21, x equals 8. So now I have x equals 8, and I want to find my y. So I'm going to plug it back in, okay? It doesn't matter which one you plug it back in for, just pick whichever one's easiest for you. I'm going to pick the top equation here. So I'm going to go 3 times 8 plus 2y equals 48. 24 plus 2y equals 48. Subtract my 24, and I get 2y equals 24, or y equals 12. So now I have the coordinate 8, 12. That's the solution to this one. All right, so now I wanted to give you one. I'm going to go ahead and erase this just to kind of clear it up a little bit. Give myself a little bit of room here. So now I have two equations here, and I have 7x plus 2y equals 5, and I have 2x minus 3y equals 16. So we want to make sure that we can eliminate one of the variables. I already noticed that one of them is positive, one of them is negative, so I'm going to eliminate that one first. So I'm going to eliminate the y's. Well, what is a multiple of 2 and 3? Well, that's 6. So I'm going to multiply the top by 3, and I'm going to multiply the bottom by 2. So when I get up here, I have 21x plus 6y equals 15. I'm going to multiply this by 2, so I have 4x minus 6y equals 32. And now I end up with 25x equals 47, okay? And so then I'm going to go ahead and solve that. Make sure I wrote it down correctly here. And I did not. This was supposed to be a plus, which is going to force all these to be negative, which helps a lot, because that gives me 17. This gives me negative 17. So make sure you write down the problem correctly. So x equals negative 1. Just so most of these are going to be whole numbers. Okay. Now I'm going to take that negative 1, plug it back in. So I have 2 times negative 1 plus 3y equals 16. Negative 2 plus 3y equals 16. 3y equals 18, or y equals 6. So now I have the coordinate negative 1, 6. The last thing we're just going to briefly talk about is this idea of revenue, cost, and profit. So revenue, or Rx, is going to be the price per unit sold times how many units you sold, where X is the units sold. Okay, or the cost of C of X is the fixed cost, so you're going to have those fixed operating costs plus cost per unit. Okay, so you're going to want to find this out. Now your profit is your revenue minus your cost. So this is very common to utilize these in business, and you can kind of see that there's some application to this. So that's kind of solving systems of equations.